Hi everyone, I'm Praful John, and in this walkthrough, I'll demonstrate part one of my deep learning assignment where I have explored a variety of data augmentation techniques using Keras, TensorFlow, and Fast AI. In this one, we demonstrate the foundational techniques for improving model generalization and preventing overfitting during the training process. We'll be using L1, L2 dropout layers, batch normalization, early stopping callbacks, and tensor board integration. So we start by setting up and loading the data set. In this step, we are doing the model with L1 and L2 regularization. Then here we add the dropout and batch normalization, and here we use early stopping and tensor board callbacks, early stopping tensor board, and then we compile and train the model. Once we are done with that, we get a very generalized model basically. So here we are doing some advanced regularization and visualization. We'll be using Monte Carlo dropout layer and a custom regularizer example. We'll use model with MC dropout and MYL1 layer, and then we'll compile the model, train the new model, and this is the visualization. This is how the loss and accuracy curves looks like. In the next one, in this notebook, we explore advanced augmentation techniques made accessible via Keras CV, which is a modern augmentation tool kit built on top of TensorFlow. The key highlights are Keras CV dot layers augmentation layers. We used layers like random flip, random zoom, random rotation, and random contrast, etc. And here we do augmentation pipelines and combine multiple transformation to simulate diverse real-world image conditions, and we do before and after visualization as well. So we start by importing all the libraries we have, then we load the CIE FAR10 data set, which have struct mobile and everything, and horse, ship, etc. We define basic augmentations. Here we visualize augmented samples, so it is flipped, and rotated images. Um, yeah, horizontally random flip and rotation and zoom. So that is what how we augmented the images, and then we compose augmentation in this step. Then we define a simple CNN model, and we train the simple CNN model on top of the augmented images, and then we visualize the result. So this is how the validation and test logs looks like. In this collab, we focus on image augmentation using Ogilvy with effects like blur, perspective transformation, distortion, and more. And we also perform text augmentation using NLP AUG with operations like synonym replacements and word swaps. And we also do time series augmentation with jitter scaling and noise injection to simulate real world variations. And we also do tabular augmentation, speech augmentation, and document image augmentation as well. So we start by importing, we load an image, and we display how we have like different perspective blur and original one. Then we do the text augmentation. This is augmented text, and then we do multimodal augmentation for time series, tabular, speech, and document. So this is for the time series one. This is for the tabular one. We did took tabular one and changed. We added some noise in that data, and in the speech we applied pitch shift for the speech, and similarly for the other one as well. Now we'll be using fast APIs, and we'll use the data block API to define input pipelines and awk transforms. So we'll start with installing the fast APIs, and then we define label function, and we create data loaders and visualize how the images looks like. And then we create a CNN model, train the CNN model on that. It took a lot of time, and then we plot the confusion matrix. So that's it for this one. We'll be continuing this in the part.